minus 50 degrees Celsius. Since a typical freezer is around minus 18 degrees, this is 3 times colder than that. In 30 minutes, your mind goes blank, and in an hour, your heart stops. Yet, the Inuit people living in the Arctic piled up snow to build houses in this killer cold, eating and laughing inside them. Do you know what's even more surprising? The temperature inside that snow house can go up to 20 degrees Celsius. It is minus 50 degrees outside, but 20 degrees above zero inside. That's a massive temperature difference of 70 degrees. They created a space where you can wear short sleeves in a place where you should freeze to death. How on earth is this possible? How can a house made of snow protect people from freezing to death? Today, we will uncover the secrets of this amazing survival technique one by one. Many people think an igloo is a house made of ice. However, this is a completely wrong misconception. The material for an igloo is not ice, but snow. And they don't just use any snow. The Inuit carefully select and use only snow with a specific density and texture. Why is this difference important? Looking at the structures of ice and snow under a microscope reveals the answer. Ice is a solid where water molecules are tightly bonded together. There is almost no empty space between the molecules. Therefore, heat transfers quickly. Simply put, if you have an ice wall between you and the outside, the cold outside air comes right inside. Being inside an ice house is no different from being trapped inside a freezer. On the other hand, snow has a completely different structure. Countless tiny air pockets exist between each snow crystal. According to scientists' analysis, in the compressed snow used for igloos, about 85% to 95% of the total volume is filled with air. This is the key. Air hardly transfers heat. It transfers heat almost 100 times less than ice. We can find a similar principle around us. Think about the thick padded jackets we wear in winter. What is inside them? Duck down, goose down, or synthetic cotton? What do these have in common? They create numerous air layers. The air trapped between the feathers and the cotton prevents body heat from escaping outside. The snow walls of an igloo operate in exactly the same way. But an important question arises here. No matter how good the insulation is, it is useless without a heat source. Just like an empty thermos can't keep anything warm. Where on earth does the heat inside an igloo come from? The first heat source is people. Our bodies are living heaters. Even when an adult is just sitting still, they continuously emit heat. To give you an idea of the amount, it's like continuously radiating the heat of one bright, incandescent light bulb. Even with just 3 or 4 people inside an igloo, a massive amount of heat is constantly generated. The second heat source is a small traditional lamp called a quillic. It produces heat comparable to a small modern electric heater. Adding just this one heat source raises the internal temperature of the igloo by several degrees. Looking at actual measurement data is even more surprising. According to an experiment conducted by the Canadian Arctic Research Institute, when the outside temperature was minus 45 degrees, the inside of the igloo could be raised to 15 to 20 degrees Celsius with just 2 adults and 1 small lamp. That's a temperature difference of 60 to 65 degrees. If more people enter or activity levels increase, it can even reach 25 degrees Celsius. However, another question arises here. Just because heat is generated doesn't mean it automatically gets warm. That heat needs to stay inside without escaping, but an igloo has a door and crevices, so how does it trap the heat? This is where the true genius of Inuit architecture shines. If you look closely at the structure of an igloo, there is an incredibly sophisticated design hidden within. First, the entrance is different. Unlike a regular house where a door is punched in the middle of a wall, it is built in a tunnel shape lower than the floor. Why did they make it this way? Think about the basic principles of physics. Cold air is heavy and warm air is light. This is due to the difference in density. Simply put, cold air is heavier than warm air, so it sinks. This difference creates natural air circulation. The cold air entering the igloo is heavy and sinks. Then it naturally flows down towards the entrance tunnel dug lower than the floor. It pools up there. Conversely, the warm air from body heat and the lamp rises. The warm air traveling up the igloo's domed ceiling circulates along the walls, distributing the heat evenly. That is why the Inuit never sleep on the floor. They build snowbed platforms about 40 centimeters to 60 centimeters higher than the floor and live on top of them. This height difference creates a tremendous temperature gap. When actually measured, the temperature near the floor is around -5 to 0 degrees, but at bed height, it rises to 15 to 20 degrees Celsius. Within the same space, going up just 50 centimeters makes a difference of nearly 20 degrees. Another amazing feature of the igloo is that it evolves on its own over time. When first built, it is just a stack of snow blocks, so there are bound to be microscopic gaps between the blocks. If the wind blows hard, cold air could seep through those gaps. But the situation changes when people go inside and start living there. As the internal temperature rises, the inner surface of the walls begins to melt slightly. Even if it only reaches around 0 degrees Celsius, the snow's surface absorbs moisture. But what happens at night? When the lamp is turned off and people fall asleep, the internal temperature drops again. Then the melted surface freezes over again. However, this time, it turns into a solid ice layer instead of powdery snow. When this process repeats for a few days, a thin ice coating forms across the entire inner wall of the igloo. It's thinner than a fingernail. This thin layer of ice perfectly seals all the gaps. No matter how strong the wind blows, it cannot penetrate inside. Moreover, thanks to this ice layer, the snow walls become harder, increasing structural stability as well. What's interesting is that this ice layer does not get too thick. This is because behind it, there is still a snow wall made of over 90% air. That snow wall prevents the extreme cold outside from reaching the inner ice layer. Therefore, the inner ice doesn't drop significantly below freezing and maintains a temperature around 0 degrees Celsius. The igloo practically has its own self-regulating system. Size is also an important variable. If the igloo is too large, heat loss increases. As the space gets bigger, it becomes harder to keep it warm. Therefore, traditional igloos are limited to about 3 to 4 meters in diameter. With this size, it is sufficient for a family of 3 or 4 to live in while maintaining the temperature using only body heat. The wall thickness is also precisely calculated. If it's too thin, there's no insulation. And if it's too thick, there's a risk of collapse due to its weight. The optimal thickness is roughly between 30 and 60 centimeters. This thickness is structurally sturdy and provides adequate insulation. In fact, filming with a special camera confirms that heat loss through snow walls of this thickness is extremely low. The dome shape is not a coincidence either. A spherical structure is the shape that requires the smallest surface area to enclose the same volume. A smaller surface area means the area where heat can escape is reduced. In addition, the round shape minimizes wind resistance. Even when the strong Arctic winds blow, they flow along the igloo's surface, dispersing the pressure applied to the structure. How do they ventilate? People exhale carbon dioxide and burning lamps create smoke. The Inuit cleverly solved this as well. They poke a very small hole right at the top of the ceiling. It's just a tiny hole about the size of a coin. Polluted air escapes through this hole. Warm air has lower pressure and tends to rise. So, it naturally exits through the small hole in the ceiling. At the same time, fresh air slowly comes in through the lower entrance tunnel. Since it's cold air, it immediately sinks to the floor. Even though natural ventilation takes place like this, heat loss is minimized. This is because the hole is so small and the airflow is slow. Analyzed with modern science, the igloo's efficiency is even more astonishing. As a result of experts measuring its insulation performance, it was revealed that a snow house made with ancient technology is comparable to or even superior to the insulation standards of modern exterior walls. It is also marvelous in terms of energy efficiency. To keep an igloo at 15 degrees Celsius, the body heat of 2 adults and 1 small lamp are enough. On the other hand, to keep a standard tent of the same size warm in the Arctic, a much more powerful heater is required. An igloo is over 5 times more efficient. Another fascinating point is humidity control. When people breathe and cook, water vapor is generated. In a regular tent, when this water vapor touches the walls, water droplets form, making the walls wet. This drastically drops insulation performance and gets clothes wet. But in an igloo, this rarely happens. The water vapor disperses as it seeps into the microscopic pores of the snow walls. Some attaches to snow crystals to become frost, and some passes through the wall to the outside. Even with an ice layer on the inner wall, it's not entirely airtight, so water vapor can slowly move. Thus, the inside of the igloo maintains a relatively dry state. This also has the effect of raising the perceived temperature. The Inuit developed additional techniques to stay warmer inside the igloo. By laying multiple layers of reindeer or seal skins over the bed platform, they completely block the cold rising from the floor. While sleeping, they get into thick fur sleeping bags, and the insulation performance of these bags is remarkable. Even in a -40-degree environment, the inside of the sleeping bag can be kept above 20 degrees Celsius just with body heat. Cooking food is also part of heat management. Boiling hot food raises the indoor temperature by a few degrees and produces water vapor. The Inuit calculated this and cooked during the coldest times of the day. The heat and moisture generated while cooking made the inside of the igloo warmer and more pleasant. It was killing two birds with one stone. In modern times, as scientists study igloos, new facts continuously come to light. In a study published in 2018, the airflow and temperature distribution inside an igloo were recreated in 3D using computer simulations. The results proved that the design the Inuit learned through experience is scientifically close to perfection. Another research team calculated the optimal density of snow used for igloos. Fresh snow that is too light is structurally weak, and tightly compressed snow has reduced air content, lowering its insulation performance. There needs to be snow of exactly the right density. Amazingly, the Inuit have used their experience over thousands of years to accurately select and use snow in that optimal range. NASA has also taken an interest in the igloo. When establishing bases on Mars or the Moon, local materials must be utilized, and they believed the principles of the igloo could be applied. Mars has ice, and the polar regions have dry ice. Research is underway to build igloo-style structures with these materials to block radiation and regulate temperatures. Ultimately, an igloo is not simply a house made of snow. It is the crystallization of science and art, created by thousands of years of observation, experimentation, and desperate efforts to survive. From material selection to structural design, air circulation, and humidity control, every element is a precisely calculated system. Even when analyzed with modern science and technology, its level of perfection is so high that it is hard to find areas for improvement. The very fact that a space capable of sustaining life in extreme environments was created using readily available materials is marvelous in itself. It is a perfect survival system that operates purely on the laws of nature, requiring no electricity or fossil fuels. The greatest lesson we can learn from the igloo is the wisdom of understanding nature and utilizing its principles. The Inuit did not view snow and ice as enemies. Instead, they deeply understood their properties and transformed them into tools for survival. The harsh -50-degree environment ironically provided the ultimate material to build their homes. No matter how far technology advances, the laws of nature remain unchanged. Heat moves to cold places, air moves according to its weight, and different materials have different capacities for heat transfer. The igloo is the end product of perfectly grasping and utilizing these immutable laws. And that wisdom remains valid today and will continue to inspire us going forward. If you haven't subscribed to this channel yet, today is the perfect day. A single like helps make the next video. This was G Now, easily breaking down complex science right next to you.